On the evening of July 30, 2025, at precisely 5:40 pm from the quiet coastal spaceport of Sriharikota, India prepares to witness a moment of history. The GSLV F-16 rocket stands poised on the launch pad, but its payload is far from ordinary. Inside it is a technological marvel, a satellite called NISAR, set to redefine how humanity observes and understands Earth. This isn't just a routine launch. It's the result of an extraordinary partnership between ISRO and NASA, two space agencies coming together with a shared goal: to build the most advanced Earth observation satellite the world has ever seen. NISAR, short for NASA ISRO Synthetic Aperture Radar, is a one-of-a-kind satellite. It's the world's first mission to use dual-frequency synthetic aperture radar for Earth observation. Unlike traditional optic satellites, which depend on clear skies and daylight, NISAR will use radar to observe the planet in all weather conditions, both day and night. What makes NISAR revolutionary is its use of two radar systems working together. L-band radar, built by NASA with a wavelength of 24 cm. S-band radar, developed by ISRO with a wavelength of 10 cm. Each radar is tuned to sense different things. The L-band can penetrate deep into forest canopies, ice, soil, making it ideal for monitoring glaciers, underground shifts and biomass. The S-band, on the other hand, is more responsive to surface level changes like urban deformation, crop patterns and landslides. Together, they form a radar vision so sensitive that NISAR will be able to detect changes as small as 1 cm on the Earth's surface. At a cost of around $1.5 billion, NISAR is one of the most expensive and advanced Earth imaging missions to date. And it's not just for scientists or governments. All the data from NISAR will be made freely available to the world. Within 1 to 2 days or within hours in case of emergencies, this satellite will offer critical information to researchers, decision makers and communities across the globe. Once it enters low Earth orbit at an altitude of 743 kilometers, NISAR will begin its sweeping survey of the planet. Every 12 days, it will conduct a complete scan of Earth's landmass, covering forests, cities, rivers, glaciers, plains and coastlines. It will orbit the planet 14 times a day, gathering terabytes of data on how the Earth is shifting, changing and evolving. This data will serve a vast range of purposes. By detecting even minor movements in the Earth's crust, NISAR can help monitor and predict earthquakes, volcanic eruptions and tsunamis. It can also track floods and landslides in real time, potentially saving lives. Climate change research. It will allow scientists to study melting ice sheets, rising sea levels and shifts in ecosystems with unmatched detail. Agriculture and natural resources. With the ability to measure soil moisture, crop health and biomass, it will empower farmers and planners to better manage food security and water resources. Urban planning and infrastructure. NISAR can identify infrastructure stress, ground deformation or subsidence, making cities safer and more resilient. This mission turns Earth into a monitored living system, not just a map, but a dynamic organism whose movements we can finally observe with clarity. At the heart of NISAR is its most eye-catching feature, a 12-meter diameter radar reflector antenna made of a delicate gold-plated wire mesh. It's the largest such antenna ever deployed by NASA. During launch, this enormous structure is folded like a giant umbrella, tucked snugly inside the GSLV's payload fairing. Once in orbit, it will unfurl and spin, acting like a huge radar dish in space, beaming signals to Earth and collecting the echoes that bounce back. The level of detail and precision this antenna allows is unprecedented. With it, NISAR can map terrain, ice sheets and human settlements with centimeter level accuracy. NISAR was originally set for launch in early 2024, but during critical pre-launch tests, engineers discovered a serious issue. The radar reflector, when folded inside the rocket, was vulnerable to overheating from solar exposure. If it got too hot during the launch phase, the antenna would warp, threatening the entire mission. To solve this, NASA engineers made the decision to ship the antenna back from India to the Jet Propulsion Laboratory in California. There, it was analyzed and treated with a special reflective coating designed to reflect sunlight and maintain safe temperatures. The antenna was then retested, passing all simulations for extreme heat conditions. But even with the hardware issue fixed, the launch couldn't happen immediately. Engineers identified a high-risk orbital window between October 2024 and February 2025, where rapid shifts between sunlight and shadow could cause temperature spikes. To avoid this, the launch was rescheduled for July 30, 2025, the next safe opportunity. This delay, though frustrating, was necessary. It reflected the mission's uncompromising commitment to reliability. After all, a mission of this magnitude must get everything right. Once it's in orbit, there are no second chances. As tradition and science intertwine, ISRO chairman S. Somnath Narayan and his team visited the Sri Chengalamma temple in Solarpet in Tirupati district ahead of the launch. Seeking divine blessings for a smooth mission, they offered prayers for success, a reminder of the deep human connection behind these enormous scientific endeavors. Narayan said, with the NISAR launch, India will once again fly the flag of victory. And it's not just symbolic. This mission places India firmly among the global leaders of space-based Earth science. As GSLV F-16 lifts off, carrying NISAR into orbit, it does more than carrying machinery. It carries hope. Hope for better disaster prediction, more responsible climate action, and smarter use of Earth's resources. It's a guardian in space, quietly watching, measuring, informing. From melting glaciers in the Arctic to forest loss in the Amazon, to soil movement beneath our cities, NISAR will observe it all. And the best part, its data will be open to the world, to scientists, educators, governments, and ordinary people. Because protecting Earth isn't the job of one nation, it's the responsibility of all of us. In the age of rising sea levels, extreme weather, and rapidly changing ecosystems, we need eyes in the sky that see more than just pictures. We need instruments that measure, monitor, and warn. NISAR is that instrument, a shared gift from India and the United States to the world. It's not just a satellite, it's a sentinel, a scientific powerhouse, and a symbol of what we can achieve together when we unite for our planet.